All right, this section 2.2 is in reference to fitting the lines to data. So let me say something about, I want to make sure you understand the concept of this particular section before I go into detail. Do you agree and understand that if I give you an XY table, that's just data, it's just information? Do you understand what I mean when I say it's data? Do you understand that if the government keeps all of our personal information, that's data? Do you agree that's data? How much you swipe your card, do you understand that that's considered data? How much money you spend on your groceries, on your life insurance, on your medical insurance, that's all data, right?
Yes.
Okay, so can I create an XY table from any of that information about us?
Yes.
Yes. So anytime I use the word data, it just means it's an XY table. It might mean X is month, and it might mean the Y is how much your cell phone bill is. It might mean X is how old you are, and Y is what you pay for your car insurance. So you see how all of that's considered data? Now, in the previous section, did you have to create your own equation if they gave you enough information?
Yes.
Yes, you did. Did you have to use y equals mx plus b? Yes. Did you have to use y minus y1 equals m times x minus x1? Yes. That helped us to create our own equation, right? Okay. Well, guess what? We have a tool that'll create it for you. You told me that now, and after I done did all that work, yes, there's a tool that we're going to use that'll actually create the equation for you. So as we go on and start creating equations, you'll get a chance to see where you can actually have the equations be created for you. So that's what this chapter, this particular section is about. When it says fitting lines to data points, it just means creating the line, the equation of the line for the XY table. Creating a line or an equation that will come as close to matching the data as much as possible. Okay? So, with that said, let me write this on the board really quick. Do you guys remember the very first couple of days I gave you an XY table that looked something like this? And I said this, 1, 10, 2, 20, 3, 30, and 4, 40. And I use it as my washer dryer, my dryer example. Put one thing in, you get one thing out. Is this considered data? Say yes.
Yes.
This is data. Is there an equation that matches that data? Yes. What's the equation? Y equals, well, how you put 1 in and get 10 out? 2 in and get 20 out. What are we multiplying by? 10. So this is the equation for that data. Done. That one was an easy one. You could create that one right off the top of your head, right? So now you're going to be given data, and it's not going to be so easy that you can just create the equation right off the top of your head, but it will be able to, you can create it, and we're trying to figure out if we are given data, can you find an equation that's a close match? Do you understand what I'm saying? Is this an exact match? Yes. If I put in 1, am I going to get 10? If I put in 2, am I going to get 20? If I plug in 3, am I going to get 30? So is this equation an exact match for this data? Yes, it is. Well, let me ask you something. What if I happen to go and change that to a 2, and then this to a 7, and that to a 8, and this to a 49? Now, does this equation now match that data? No. Is there one that might come close? That's what we're going to do in this section. We're going to find an equation that comes close to trying to, if you plug in a 1, you get a 12, plug in a 2. We're just going to create, by finding an equation using the graphing tool, that'll create an equation that'll come close. It may not be an exact match, but it'll come close to matching that data. All right, so with all that said, let's go to slide number 2, which is what you're going to see in the homework for the first part. We want to know, given data, is it going to be an exact match or an approximate match? The previous table here, it was an exact match, right? Now, it's not a proper exact match for that equation. So here's what, now notice, is this still an XY table right here? Yes, it's just horizontal as opposed to vertical. So the X represents the what? The month, and the Y represents the total. We can say that's your cell phone bill. It don't matter what it is. It's just you got months, 1, 2, 3, 4, 5, and how much the money was for each one of those items for month 1, month 2, month 3, 4, and 5. Now the question is is there a linear model, which means is there an equation that will model that data exactly? Is there an equation that will fit the data exactly? And here's how you figure out the answer to that. If we do something called first differences, and if they are the same, constant means the same. If the first differences are the same, then the answer is yes. There is an equation that will model that data exactly. Well, what's the first differences? The word difference means subtract, right? Yes. So what's the difference between these two numbers?
22.
22. So if I subtract these two numbers, don't matter if it's positive or negative, just subtract these two numbers. The distance between this number and that number is how many? 22. Well, what about between these two? 22. Between 151 and 173? 22. And the same thing between 173 and 195. If that difference between each one of those is the same, then there is an equation that models this data exactly. That means we can find an equation that we can write that will give us, if we put in 1, we get 107. If we plug in 2, we get 129. If we plug in 3, we get 151. There is an equation that will give you that data exactly. Okay? You okay with that? And what do we call this when you subtract the two y values from each other? What do we call it again? It's the first difference. It's called the first difference. All right, next slide. Let's take a look at this one. What changed? Y'all tell me what changed.
The difference?
The differences are now different. Why? Because they changed, some of these numbers up here got changed. So now when I do the first difference is, the difference between 107 and 129 is $22. The difference between 129 and 153 is $24. The difference between 153 and 174 is $21. And the difference between 174 and 195 is $21. So now, are the first differences the same like it was on the previous slide? No. But are they kind of close? They are kind of close. Where you see it says nearly constant, it means they're nearly the same. They almost the same, but not quite. So if I'm looking to create an equation to model that data, is that equation going to be an exact match or an approximate match? Approximate, because these numbers are kind of close, but they're not the same. You're good? You're good? Okay, all right. So we're trying to figure out, if you get data, can you tell me if there's an equation that's going to model it exactly, approximately, or not at all? Is it possible to have some data where ain't no equation going to match it? Absolutely. Absolutely. So let's look at the next set. Here we go. Your turn. Is there an equation, a linear equation, that will model this data exactly, approximately, or not at all? What are we supposed to do? Y'all saying exactly? Well, how you know that?
The first difference is the same.
What's the first difference between 7 and 4? And 7 and 10? And 10 and 13? And 13 and 16. So there is an equation that will model that data exactly. So far easy, right? Okay, all right, let's do the next one. Your turn again. Look at the data table. All righty, so let's do the first differences again. What we got? 6, okay. 8.
7.
All right, is there an equation that will model, a linear equation that will model that data exactly, approximately, or not at all? Approximately, because those numbers are pretty close together. Yes.
We always look at the y values.
Always.
Not the x values.
Not the x values, always the y values. And with the x values, they should be the same distance apart. So for example, that's 5, plus 3 is 8, plus 3 is 11, plus 3 is 14, plus 3 is 17, plus. So these should be all distance, the same distance apart. So we had 1, 2, 3, 4, 5, 6. They should all be the same distance apart, but you never have to look at it because they will be. Okay? So only pay attention to first differences for the y values. Do not do anything to the x values. All righty, next one. Here we go. Approximately, exactly, or not at all?
3. 5.
Approximately, exactly, or not at all? Approximately. These three, are these numbers kind of close together? 2, 3, and 2 and 5 are kind of close together, so I would say approximately. Does it matter that this number jumped down and went smaller? No. I just want to know how far are they spaced apart. Yes.
How big of a difference will it be until it's no longer approximate?
That's the question that's for the, let's see. How far of a big difference would it should be? Oh, I'm trying to get to my next slide. All righty, let me give you an example because I thought I had one up here. All right, so let's say, I'm just going to create my own table over here, guys. And so let's say we've got my XY table here. All right, 1, 2, 3, 4, 5, 6, 7. And down here, I've got 10, 45, 100, 200, 615, 1,000, and 1,020. All right, I want to know if there's an equation that will match that data. All right, well, let's look at what's the difference between 10 and 45? 35. All right, now 45 and 100. 65. 100 and 200? 100. Now what? 615 and 200? 415. The difference between here and here? 385. And then the last two? Now, what you think? No. Now, here's how you get a better picture of that. You're like, well, I might say approximately. I would say not at all. But here's how you get a better picture of that. If you had to put this in Desmos, here's my x-axis, here's my y-axis, and you got to now plot these points. So you got 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 1. So again, I'm just plotting the points. If we plot these points, and it's got to go all the way to 1,000. So again, if we just put these here, I'm just making these up, going all the way up. So again, if I've got 1, 35, 1, again, if I'm counting by, if I count by tens, you know 1,000 gonna be through the roof, right? So let's count by hundreds, just for sake of easy math. 200, 300, 400, 500, 600. So again, if I've got 1, 35, let's say 1, 35 is right there. 2, 45 might be right here. Then I've got 3, 100 right here. And then I've got 4, 200 right here. So again, can you see? I'm trying to see if it creates a line or not. What's the next one? 5, what?
615.
All right, there's 615 way up here. And what's the next one? 1,000. That says 7, 8, 9, and 1,000 is way up here somewhere. And then 120 is right there. Now, the question is there a line that you can draw that's going to touch all of those points? A straight line. Can't be a curved line. We ain't saying dot to dot. No. Can you draw a straight line that's going to touch all of these points? No. That's the question. So now, is that a good representation of a line, of an equation of a line? Probably not. So the question is, to answer your question, this is not a good fit for this data. So here's what your points should look like if it is a good fit. Does that look like it's a good fit? Now, can I draw a line that's going to hit most of these points? Yes. Is that line a good fit for that data? Yes. Is it exact? Does it touch every single point? No. But is it approximately? Yes. All right, well, what if my data looks like this? Here's my x, again, here's my y. There is no equation that's going to fit those data points because you can draw a line, but it ain't going to come close to none of them. So that's what you're asking yourself when you say, is there a line or a linear equation that matches the data? Is there a line that comes close to all of the points? If they hit every single point, it's an exact match. If it hits most of them, it's approximately. If it don't hit none of them and they all spaced out, then it's not at all. So that's how you want to tell if it's a good fit or not. Now, I can tell you this in advance. One or two of them in the homework, they call it exact or approximately, and I wouldn't have picked that answer. So just know that you're going to get one that you might disagree with my math lab, and I disagree with it too. All right, so you okay with doing this? What is this called? Finding the what? We got the data point, but we're finding the first difference so that you can tell if it's a what? If you find the first difference, why did you have to find the first difference? To see if there is a linear equation or function that matches the data, that matches the data table or the XY table. We got it? All righty. So this is the same thing. The word, when we say find the linear equation, you're looking for something called linear regression. That word is called linear regression. If it wants to know what's the best fit, can you see that this line is the best fit? Is this line the best fit over here for this data? That's what they're going to ask you for. What's the line that's the best fit for the data? You don't have to create it. We have a tool that's going to create that equation of that line for you. Okay? So, next thing. All right, we're going to create a scatter plot. So, you're going to have to go to Desmos. Before you go there, we'll go ahead and pull it up. But before you finish getting there, I want to know what the first difference is.
5, 4, 2, 2.
What you thinking so far? Is there an equation that'll fit that data? Approximately, exactly, or not at all? Approximately. Okay, so now let's go put this data in Desmos. You know how to type a data table in Desmos, right? You forgot. In Desmos, go to the top left, hit the plus sign on the top left. Top left, hit the plus sign, and it should bring down a little box of, you should pick the one that looks like an XY table. Type those in vertically, like they should be typed in. Put them in vertically. Let me know when you got them typed in. Who's got the sign-in sheet? Anybody else need the sign-in sheet?
I need,
Just pass it wherever you need to pass it to. You finished typing them in?
do you press enter?
It should go down to the next one. You can tab down to the next one. Each time you put one in, tab down to the next.
After I put it all in.
Oh, after you put them all in, can you see your dots?
Yes.
If you can't, what's wrong with your window? How big should your x-axis be? Look how big. How big should it be?
16.
At least 16. I would make it 20. How big should your y-axis be? At least 27. I would make it 30. So you can't see anything if you don't change it. Yes, ma'am?
I had to zoom in.
Gotcha.
Zoom.
You can zoom in or out so you can see your window as well, or increase your window as well. How many points should you see on the screen?
8.
7.
Yeah, there should be about 7 points on the screen. 7 dots. You see 7 dots on your screen? Do they look like they're in the shape of a straight line?
Yes.
So, would you say there is a linear model or equation or function that models that data exactly, approximately, or not at all? Does it? Because again, if you draw a straight line up through those points, is your straight line going to hit every single point?
No.
Is it going to get close to it though?
Yes.
Yes, so that means approximately there is a linear equation that we can create that's going to come close to all of those points. That's what we're looking to do. You don't have to create the equation, we're going to create it for you. So now it says, now create the linear model. Anytime you see the word model, what does that mean? Equation. Now I want you to create the linear equation that matches that data, but not by hand. We don't even have to do it by hand. So I need you to go to something called xuru.org. I'm going to pull it up on the screen. But before I pull it up on the screen, let me go to Desmos and put those points in. Hold on. Don't y'all leave me. Okay. Somebody read me that table.
2, 5,
2, 5.
5, 10.
Okay, 5, 10. Whoops. Okay.
8, 14.
8, 14. Go. 9,
9, 16.
16. Okay.
10, 18. 12, 21,
Okay.
and 16 and 27.
Alrighty. Now, if my points aren't here, that means I gotta go change it or zoom in or zoom out, whichever way I wanna see all my points. There they are. Okay? My points look like a straight line, almost. Is it a perfect straight line? Nope, it's not a perfect straight line, but it come kind of close. It depends on how you set your scale too, so it's very close. Now I want to know what's the equation that matches those dots up in a straight line, as closely to a straight line as it possibly can make it. What's the equation? I don't know. So we got to go create it. So let's go to Zuru. So let me put this up on the screen so you'll see it. This is called www.xuru.org. Go there. Tell me if you have this screen. Click on Regression Tools. We're creating regression equations. So click over to the left. It says Regression Tools. Click on Regression Tools, and you should have this screen at the top. This is the important screen. What kind of equation are we trying to create? Linear. So click on linear regression. Notice there's some different ones up at the top. This one's linear, this one's logarithmic, this one's exponential, this one's power, this is polynomial. We don't use the rest of them, but we will use the first 5 in this class. So you should put favorites for this page. So the first one we're going to do is linear. How do you know that you're on the linear regression screen? It better say linear regression at the top. If you're not going to get the right equation. Now, from the homework standpoint, you're just going to be cutting and pasting the data in here. Right now, we're getting ready to type it. Yes. This is xuru.org. And then click on regression, and then linear regression to get this to pop up on the screen. Or you can just click LR over here at the top. It should say LR at the top left, at the top of the screen towards the left. You got it? Now, from the homework, you're going to cut and paste your data in here. Right now, we get ready to type it. All righty. So we got to go back and type our data in here from the previous screen. Let's see. Let me go back and look at it because I forgot what it was. Did y'all remember? Let me shrink it so I can. Yeah, I'm going to make it so I can see them both at the same time. Hold on. Let me minimize this screen. And scoot this over. And shrink this one a little bit. So I can see both of my screens at the same time. All righty. So now I am going to type my data. Like I said, with the homework, you can just cut and paste. 2,5. Do I have to type it like it's 2,5? Yes, you do have to put a comma between the 2 and the 5. 8, 14, 9, 16, 10, 18, 12, 21, and 16, 27. Let me know when you finish typing yours in. You literally have to type them in or paste them. When you get to the homework, you'll be able to cut and paste them. So I need to show you how to do that before you leave today. Okay? Do you have the same table typed in here yet? Almost. Why are we doing this?
To
Find the equation that matches the table of the data. All right, if you got it, hit the word calculate at the bottom of the screen. See that? See where the word results is? That's all you care about. Don't look at nothing else on that page, but where you see the word results in red, that's your equation that matches this data. That's your equation. Then you like, well, do I have to type all of that in as part of my answer? The homework will tell you how many decimal places it wants. If it wants 3, what you gonna say the answer is? Y equals 1.57.
5, 7, 6.
If I want 3 decimal places, 5, 7, 5, 7. I got to round.
Oh.
I got to round. If it wants 3 decimal places, that fourth 6 or the 6 in the fourth place is going to cause the other 6 to become a 7. Alrighty, so 1.577x plus what? I need 3 decimal places, 1.892. I don't have to do any other rounding for that one. That is the answer for that particular problem. So the homework is going to say, what's the linear model, or what's the linear function, or what's the regression equation for that data, and you're going to type that in as your answer. Now remember, last chapter, we did all of this work with creating the equation ourselves. You don't have to create the equation, it will create it for you. We're good? Okay. That's not so bad, right? Okay. Alrighty, so that was from that slide. So let me go back to the PowerPoint again and pull it back up. All right, did we create the equation? Yes, we did. So now let's look at a couple of other slides before we finish. Discrete functions, meaning discrete equations, and continuous equations. One has a finite number of inputs, and the other one has a continuous, infinite number of input values that you could use. So I'm going to give you an example of both. In the coming slides, I'm going to give you an example of what it looks like when it's discrete and what it looks like when it's continuous. That'll still be one of the questions from the homework. And the homework is going to ask you also, if you look at the model and you look at your data points, is this considered interpolation or extrapolation? Let's see what it says. Interpolation is use the model to find information that lies within the given data points. Extrapolation means use the model to make a prediction based upon the input that's outside the data points. All right, one deals with the data inside the table, one deals with information outside the table. Interpolate means inside, extrapolate outside. You got it? Okay, so we'll go over this, an example of this in a second. So here we go. Let's talk about how this relates back to real life, what we just did. All righty. Let's read and see what it says. Math and context. If $1,000 is invested at 6% simple interest, the initial value and the future value called S, we're calling the future value S, at the end of 5 years are shown in the table. All right. So instead of X and Y, what letters are they using? T and S. T is time. Most of the time, T will represent time, whether it be seconds, minutes, years, months, whatever. T usually represents some sort of time. All right, future value is S. Now, let's see if we can answer the bullets. Can a linear function model this data exactly? Can a linear function or equation model this data exactly, approximately, or not at all? Exactly. Why would you say exactly? What's this called that I'm getting ready to do? First difference is how much? First difference? First difference? So again, since all the first differences are the same or constant, you'll see that word constant, which means the same. Is there a linear equation that'll model that data? Yes. If so, find out what that linear function is. Find out what that linear function is that models this data. Now, remember, where we're going to take and put this data? In Zuru. So, go ahead, type. That is an easy one. That's a very easy one. What's your equation? Should it end up in y equals mx plus b form?
Yeah.
Yes, because we're still talking about linear equations. So, yes, ma'am.
It's LR, not LNR.
It's LR. LNR is logarithmic, and we won't get to that till the very end of the semester. Okay, you got it all typed in? You calculate and tell me what the equation is.
Y equals 60x plus 1,000.
Tell me if y'all got that answer. Is that the equation you got?
That's the equation or linear function that models that data. We okay? What you thinking? Now, on the homework, it's actually going to make you write this equation slightly different. Can you tell what the difference is how they're going to make you write this equation?
Dollar.
Okay, we do have some dollars here. What else?
The variables.
The variables. What are they using? So instead, if you put this in the homework, it's going to mark it wrong, it's wrong, it's wrong. Even though I know it's right, it's going to mark it wrong. What do you have to change this to? Now it's right. Just make sure you use the variables they use. Okay? All right, that was bullet number 2. We just finished bullet number 2. Find the linear function. We just created it using Zuru. All right, bullet number 3. Use the model to find the future value of this investment at the end of 7 years. What should I do? Okay, so I want to know how much money is going to be in my account, not 5, 6, but 7 years later. Tell me what to do now. Plug 7 into my equation that you just created. So in the place of this T, put a 7 and then do the math on your calculator. If you can do it in your head, that's wonderful. All right, so plug a 7 in here. All right, 60 times 7 is what? 420 plus 1,000 equals. All right, so now, at the end of what? At the end of 7 years, I will have $1,420 in my account, based upon the interest that I'm earning, right? Now the question is that an interpolation or is that an extrapolation? Well, it's extrapolate because look at the data table. We're talking about from 0 to 5 years. Is 7 years within the table? No. So that's extrapolation if it's outside the data table. If I had asked you for how much money will I have in 3.5 years, would that have been interpolation or extrapolation? Is 3.5 in between these numbers in the table? Yes, that's considered interpolation. You got it? You understand the difference now between interpolation and extrapolation? Okay? So you're right, that is extrapolation. Now, should this model be interpreted as something that's discrete or continuous? Discrete means finite. Discrete means it stops. Does this data table stop? What year does it stop at? At 5 years. Done. It just literally stops. Would you normally want to know how much money you're going to have at 1.1 month? At 2.23 months? No, when you're putting money in any type of investment, you're not going to watch it every week to see how much. You see what I'm saying? You're not going to go necessarily check it because you ain't going to make that much money in 1 week, are you? No, you're not. So again, when we're looking at this as discrete, we're saying usually we're going to stick with looking at it for 1 year and another year and another year. We're not going to look at it for 3.359 years. You understand what I'm saying? So this is a discrete model. It's a finite number of years that we're looking at. And you usually wouldn't look at it any other way. You got it? All righty, let's look at the next one. Last one for this one. All righty. Can a linear function model this data exactly from the table? And I don't want you to put this in decimals because it's too much to type. But I want us to get an idea. So here, can the function be modeled exactly? All right, somebody use a calculator. What's the difference between 3665 and 367250? Is that 650? I'm just trying to do the math in my head. 750? Okay. What is this one? 750. This one? 750. This one? So, is there an equation or function that models that data exactly? Yes. Yes, because the first differences are all the same, or they're all constant. So now, it wants to know what's the equation. We're not going to go type it in, okay? We're not going to type it in
to see exactly what it is, but you know there is an equation that models the data exactly. Where it says verify that the equation you created works, it literally wants you to go plug in 30,100 into the equation and see if you get 3680. It wants you to go plug in 30,100. You can't see it because I've got a data table. It says verify that your equation is the right equation. Plug 30,100 into your equation, and what should you get? 3680. Over here, come over and plug in what? 30,300 and see if you get 3,710. Well, what's this table about? What's the table about? Taxable income. Is that time coming up? Yes, it is. So, depending on how much money you make, they call that your taxable income, and the number that's in the second row is how much money you owe to the IRS, right? That's what that table says. Again, this is the table that we just made up. So now I have a question. Bullet number 4, the model for this can be interpreted continuously. Use it to find the tax due on total income, a taxable income of $30,125. Alrighty, 30,125. Where is that? Where would that fit in this table? Between this one and this one?
Yeah.
Yes. Is that considered interpolation or extrapolation? Extrapolation. Interpolation. Now, I got that, but what makes it continuous? This table is a continuous. Now, I know I got a finite number of numbers up here, but do I have enough salaries in between here and here? Somebody made $30,101. Somebody made $30,000, 101.58 cents. Somebody made $30,000, 101.07 cents. Somebody made $30,000, 100. You see what I'm saying? How many different salaries are in between here? A ton. Do you understand what I'm saying? Somebody made $1 different than what you made, 50 cents different than what you made. So there are an infinite number of salaries in between each one of these. So I could go on for a long time picking salaries in between here, which is why they're calling it continuous, meaning there are a ton of other salaries in between here. Now, when we went to the previous table, we were looking at the amount of years that you're going to earn money interest. Again, we're just looking at year 1, year 2, year 3. In here, when you go to file your taxes, do they want to know the exact amount that you earn? Yes, to the penny. So there are a gazillion number of inputs or data X values that you could use in between here, so we call this continuous. It doesn't mean that it doesn't stop here. It stops here from looking at the table. But can I create a whole lot of data points in between here? Yes, I can. So that makes this model continuous. All right. We got a few minutes. I want to go over I want to give your test back and just make a quick hint about the homework. Let me find it real quick. While I'm finding the homework assignment for this 2.2 and pulling it up, I'm going to go ahead and call your name and pass your test back to you. Let me look at number 1 real quick. All right, that one's too easy. I want one that wants you to copy the data. Let me see. All right, you got some data here. I need you to look at number 10 really quick. You have some data. Do you see you've got this little double box right here at the top? That's where you copy your data. All righty? It also says X is the number of years when? After 1940. Will you ever in a table put 1940, 1945? Never. Remember, X is the number of years after 1940, so this is going to be 0, 5, 10, 15, 20, 25, 30. So you're going to cut and paste it, but you got to fix these. Never will you put the year in the table. Never, never, never. So when it says cut and paste, see this little doohickey up here? Click it, left click it, copy the clipboard. It's in blue. Now, it does not want you to have multiple commas, so you have to take those commas. See where the number says 2008-42? Can't have that comma in between there. It just needs to be a 2842.
So I'm gonna copy it. Then I'm gonna go to Zuru. Where's my Zuru at? Minimize that page. Minimize that page. Where'd I have Zuru at, y'all? There it is. Delete what I had in here. Right click and paste. There's your data. Now I gotta go change it. It doesn't want this domestic year stuff in there. Take all that out. Now change this to a 0. Alrighty, change that to a 5. And it doesn't like that comma that you see there. Can you leave a space between them? You can put a space between them or a comma between your X and Y's, but you can't have this comma here. So delete all of those out. Those commas got to come out. Whoops, I deleted my 9. Backspace. So you see what I'm doing? You got to go do this for all of your data, then hit calculate and it'll create an equation for you. All righty, so I've got about 5 minutes. So let me go ahead and give you your test back questions. While I'm giving you a test back, I have already inputted your grades into My Math Lab so you can see the effect that it had on your actual overall average. The tests were overall A's and B's. Overall, they were A's and B's. Question, I will always ask this at every test. Was the test a fair test?
Yes.
Did it cover what we covered?
Yes.
Was it similar to what you saw in the study guide?
Yes.
So can you see if you study your study guide, you do fine on the test?
Yes.
Now, on every test, I'm not going to have every problem or multiple problems that'll come directly from the study guide, but should it look similar to the study guide?
Yes.
Yes, it should, okay? So, with that said, Henry, you come and get it. You are dismissed. Robin? Courtney, Raymond? Eric? Imani? Where's Imani? If you have a question, please ask me a question. If you got points taken off and you got it right, it's because you didn't tell me why. Tanaya? Yukavia? You can keep it. I've already put the grades in. Tanaja? Kiara? Garrett? Angelo? Tamara? Morgan? Which one? Morgan? Tanaja? What'd I give you? I said you gave me.
I thought you said 15 years.
Oh, okay. Okay, gotcha. Morgan? Shanisha? No, Shanisha. McKeithen? Shanisha? Okay. McKeithen? India?
It's funny that you did in that order because that's my cousin name, Shanisha.
India? India? Colin?
Yeah.
Kobe? Alexia? No, Alexia. Satanya? Courtney? Thomas? Jacqueline? Gloria? Kristen? I know it's Taylor. I forgot it. Elena? Zakivia? Capricia? Yvonne? What did I not call? Yakaya? Yakaya. Yakaya. Okay. Yakaya, I mispronounced it because I think I called it Yakaya or something like that. And India, Alexia, Yvonne. Okay. So I've got 3.